Welcome back. In this video, we're going to go over section 6.5, which is about dividing monomials in preparation for the next section, which is about dividing polynomials. So to begin with, we're going to review some of the exponent rules that we've seen so far. So we first began with product property for exponents, which says that if you're multiplying together two expressions having the same base, you can add together their exponents. Then we'd moved on to the power to a power rule, where if you're raising a power up to a power, you can just multiply together the exponents. And then lastly, we saw the product to a power rule, which says if you have a product raised to power, you can give each of the factors inside that power. And that was where we had left it. So what we want to work on next is developing a quotient property for exponents. And so let me just give you the property here, and then we'll see where it comes from along with some examples. So this is going to be most closely related to the first of these rules, where we are multiplying and we have the same base. For this one, we're dividing and we have the same base. If you're dividing two powers of a, then you can basically subtract the exponents. You have to keep in mind which one is bigger, though. So if it's a raised to the m power divided by a raised to the n power, and m is bigger, then you can call that a raised to the m minus n power. If n were bigger, though, you'll have 1 over a raised to the n minus m power. Let me give you some examples that illustrate where that rule comes from, and then we'll see some more examples. Okay, let's start off little. So if we had x raised to the 5th power divided by x squared, just thinking about how fractions work, this is the same as having 5x's divided by 2x's, right? The 2x's from the denominator would cancel, leaving you with 3 in the numerator. And that 3 is the same as 5 minus 2. Okay, let's say that we had 10 to the 7th power divided by 10 to the 9th power. So I'm pretty sure that you don't need to write down all these 10s. So let's just pretend that I had 7 factors of 10 in the numerator. 10 times 10 times 10 times 10, and so on, all the way 7 times. And then let's say that we had 9 of them in the denominator. Well, the 7 that the numerator and denominator have in common will cancel out, and there will be 2 extras in the denominator. And so for that reason, we'll be left with 1 over 10 squared, which is 1/100th. Okay, let's try just 2 more of these. So let's suppose that we had z raised to the 4th power divided by z. Now, this is 1, 2, 3, 4 z's in the top and a single z in the bottom. If you cancel out that z from the numerator and denominator, you're left with 3 factors of z. If, again, there are more factors in the denominator, let's say z cubed divided by c to the 6th, let's say, here there will be 3 factors of z in the numerator, 1, 2, 3, 4, 5, 6 factors of z in the denominator, and you can see that 3 of them will get canceled out and we'll be left with 3 factors of z in the denominator. Okay, so that's the basis for how those exponent rules work. Let's see if we can try some examples. Okay, so here we have x to the 5th power divided by x cubed. So this will be x raised to the 5 minus 3 power, or x squared. For the next one, we have 6 raised to the 8th power divided by 6 raised to the 4th power. This will be 6 raised to the 8th minus 4 power, and that's 6 raised to the 4th power. Okay, and then we can get a number for that. That's 1,296. Okay. B cubed over b to the 5th power. This time I'm not going to write out all the b's, but we can pretend we did. Here we would have 3 b's in the top and 5 b's in the bottom. 3 of those will cancel, and that will leave you with 2 in the denominator. Okay, so next we have x to the 15th over x to the 10th. That will be x to the 5th power when you subtract exponents. Okay, 6 raised to the 14th power divided by 6 raised to the 5th power. That's 6 raised to the 9th power. And we could probably leave it like that, but I'm curious to see what it works out to be. So that's 1007769. That's interesting. The last one ended up in 696 too. No, not quite. 1296. 96 anyways. Okay. All right. So that was a fairly good sized number. 10 million and change. Right, so we're subtracting exponents. B to the 19th power divided by B to the 11th power. That will be 19 minus 11 is 8. That's B raised to the 8th power. Okay, y to the 5th power divided by y to the 11th power. This time there are more y's in the denominator. There are 6 more. So we'll have 1 over y to the 6th power. Okay, and that will do it. Okay. The next part has to do with coming up with a meaning for raising a number to the 0th power. So assuming that we're okay with subtracting exponents, let's think for a minute. Here I'm choosing 5 and 6 just kind of arbitrarily, and they could be anything that you like that's not 0. We know from our earlier work with fractions that any number that's not 0 divided by itself is equal to 1, right? 10 divided by 10 or 160 divided by 160 is going to equal 1. So whatever 5 raised to the 6th power is, divided by 5 raised to the 6th power, whatever that is, that's going to equal 1. Any number divided by itself equals 1. Based on what we just saw with the exponent rule, this 5 raised to the 6th power divided by 5 raised to the 6th power, we should be able to subtract exponents and get 5 raised to the 0th power. And so we have to conclude that that's 1. Like I said, the 5 and the 6, I just chose those to not be equal to 0, but it could have been anything. So as long as the base is non-zero, raising a number to the 0th power will always give you 1. Okay. So examples. These questions are fun because they look harder than they really are. 11 to the 11m raised to the 0th power is going to equal 1. Okay, it's not really any calculating to do. Negative 13 p squared q raised to the 0th power equal to 1. Any number that's not 0 raised to the 0th power is equal to 1. All right, the next rule we have about division is the quotient to a power property, and this one kind of is suggested by this product property. We'd had, if you raise a product to a power, you can give the exponent to each factor inside. For example, if you had 5x cubed, this will be 125x cubed. We could cube each of the factors. This one says if you have a quotient raised to a power, that you could give the numerator and denominator that exponent. So for example, 5/8 squared is the same as 5/8 times 5/8. And we know from fractions that that's 5 squared divided by 8 squared. And there's that exponent rule. We'll go ahead and finish though. We'll get 25/64. Okay, b over 3 raised to the 4th power will be b to the 4th power divided by 3 raised to the 4th power. B to the 4th power I can't simplify though, but we can simplify the 3 to the 4th power down below, and that'll just be 81. Okay, next up we have m over n raised to the 7th power. That'll be m7th over n7th. Okay, so that's the quotient property. It works just like the product property, only for quotients. All right, so the next and rest of our examples for this section involve simplifying expressions where we may need to use more than one rule, some perhaps from this section and some from earlier sections. Okay, so let's try. So here we have m raised to the 5th power, that's raised to the 4th power, and then that's divided by m to the 7th power. So the first thing I'll do is I'll simplify the numerator. Here we have a power raised to a power, so when that happens, we'll multiply exponents. 5 times 4 is 20. Down below, nothing happens. We'll have m to the 20th divided by m to the 7th. Now here's a rule from this section. We're dividing powers of m, and so we're going to subtract exponents. 20 minus 7 is 13. Get m 13. Okay, n raised to the 12th power divided by n raised to the 3rd power raised to the 4th power. We're going to simplify the numerator's done. Let's simplify the denominator. Here we're raising a power to a power, so we're going to multiply exponents. Here, any number divided by itself is going to equal 1, but also just to practice with our exponent rule, that'll give us n raised to the 0th power, which again is 1. Okay, more examples to come next. Okay, so here's 2. Take a minute, pause the video, try this one yourself, and then restart it and see how you did. Okay, so for this one, we have a quotient raised to a power. So I'm going to give the numerator that exponent, and also the denominator will get the exponent. This gives us 2 power to a power expressions to evaluate. So we'll multiply exponents, get y18 on top, and y8 on bottom. That'll be when we subtract the exponents, y to the 10th. Okay, so you can ask yourself, okay, well, is that the only way to do it? No. You could have said, well, let me simplify the inside first. Y to the 9th power divided by y to the 4th power. Let's take care of that first. This may be a little better, in fact. 9 minus 4 is 5. That's y to the 5th power squared. We'll use the power to a power rule, get y to the 10th power. With exponent rules, there's often, like almost always, more than one way of doing something. And sometimes it's better. Other times it's not really any better. Okay, so you get your choice. For the next one, we can't do what we just did because the bases are different. On the one that we did a second ago with the y's, the bases were the same, and so we were able to subtract the exponents. This one, they're a and b, so we can't do anything with that. We'll have a cubed raised to the 4th power divided by b squared raised to the 4th power. This will give us a 12 up top and b8 down below. And that's as good as it gets. Since the bases are different on these two, we can't simplify them any further. Okay, so let's try this one. This one's got a few things going. Not all is getting squared. So we're going to use come back. Okay, so let's hope that worked. Sorry, Zoom crashed on me once again. Okay, so let's try that again. So we have 7x cubed over 9y, that's getting squared. And so we're going to square the numerator first. It was 7x cubed getting squared. And then down below we'll have 9y getting squared. So next up top, we have a product getting squared. So that would be 7 squared x cubed squared. Down below, 9 squared y squared. If you don't need to do this step I just did, it's fine. I'm trying to show a lot of steps since we're just kind of starting this. 7 squared is 49. X cubed squared is x to the 6th power. Down below, 9 squared is 81. Be careful you didn't have 18 there. 81y squared. Okay. Down below, so that was 49x to the 6th power over 81y squared. All right, so next up, a squared cubed, a squared to the 4th power, then that's divided by a to the 4th power raised to the 5th power. So this one seems kind of excessive, but that's okay, we can do it. Raising a power to a power, we will multiply exponents. We'll do that again. A6 times A8, and then that's divided by A20. Okay, so then up top, we're multiplying, and so we're going to add exponents. Now we have a to the 14th in the top, a to the 20th in the bottom. That says there are 6 more a's in the bottom. We'll get 1 over a raised to the 6th power. Okay, and that does that. Next up, we want to see about dividing monomials. So here we have 42y to the 9th power. That's going to be divided by 6y to the 3rd power. We'll take care of the number piece first. 42 divided by 6 is going to be 7. Y to the 9th power divided by y to the 6th power is going to be y cubed. So when we're dividing these monomials, we're dividing the coefficients and subtracting the exponents. When we're working on multiplying polynomials, we saw that to multiply monomials, you multiply coefficients and add exponents. So in order to divide monomials, we divided the coefficient and subtracted the exponent. Almost finished. Okay, so here let's take a look. We have negative 72 a 7th power b cubed divided by 8 a 12 b 4. So let me take each kind of thing that I have in turn. Negative 72 divided by 8 will give us negative 9. A to the 7th power divided by a to the 12th. Here there are more a's in the bottom. 12 minus 7 is 5. So we'll have a to the 5th power in the bottom. We have b cubed up top and b to the 4th power in the bottom. There's one more b in the bottom. So we'll have negative 9 over a 5th b. And that's it. Okay, let's try the next one next. We have 16x to the 7th, y to the 6th power, divided by 24x, y to the 8th. So as in the last one, I'm going to take care of the number pieces first. 16 divided by 24. 16 is 2 times 8. 24 is 3 times 8. If we divide out that factor of 8, we're going to get 2/3. And then for x's, we have x to the 7th in the top, x in the bottom. 7 minus 1 is 6. We'll have x to the 6th up top. Then we have y6 in the top, y8 in the bottom. There are 2 more y's in the bottom than in the top. So we'll have just a y squared in the denominator. 2x to the 6th in the numerator, 3y squared in the denominator. Okay, and that will do it. All right, our last one and biggest one probably. So for this one, we're going to simplify the numerator as much as we can, and then we'll figure out what to do about the denominator. So take a minute, pause the video, try this one yourself, and then restart the video and then see how you did. All right, so this one I'm going to show a few steps to get this done. So the first thing I'll do is the whole numerator is stuff that's being multiplied. Since this one is a little larger, I'm going to rewrite things using the commutative property so that I can put like the same variables together. So in numbers, we have 6 times 4. X's, there's an x to the 4th power and an x squared. In y's, I see a y to the 5th power and another y to the 5th power. There was 1, 2, 3, 4, 5, 6 things. 1, 2, 3, 4, 5, 6 things. All right, 2 numbers, 2 x's, 2 y's. Okay, down below, nothing happens yet. Okay, so now that's good. I got rid of the parentheses and I put the x stuff together and the y stuff together. Okay, continuing to clean up the top. 6 times 4 is 24. X to the 4th power times x squared will be x to the 6th power. Y to the 5th power times y to the 5th power. We're going to add exponents, get y 10th power. Down below, again, nothing happens for right now. Okay, so now I've done as much as I can in the numerator. So divide the numbers. 24 divided by 12 is 2. So 2, or 2 over 1 if you like. X to the 6th in the top and x to the 5th in the bottom. There's one more x in the top. So 6 minus 5 will give 1, right? And then y to the 10th power divided by y to the 8th power with y squared. So this just ends up being 2xy squared. And you can leave off that over 1 that is in the bottom because it doesn't contribute anything. All right, that takes us to the end of this section, all about dividing monomials. We saw 2 different exponent rules that were new. In the next section, we'll go on to dividing polynomials. In the meantime, let me know if you have any questions, and have a great day.